Okay. Lesson on perpendicular and angle bisectors. It is a line segment array that is perpendicular to the segment at the midpoint of the segment. So we have to find the midpoint of the segment and then have a perfect perpendicular line, which means it is making a right angle. So we would to find the perpendicular bisector of AC, find the midpoint of AC, so at the middle, get as close as I can to the middle. And then it's going to go straight through. It might cross through B, it might not. And it makes a right angle. So in ABC, DE is a perpendicular bisector. So that right there is 90 degrees. AD is 2y plus 4. So that's 2y plus 4. And CD is y plus 12. Let me just change colors real quick. Y plus 12. And the angle EDC, so that angle right there, change colors one more time. EDC is this whole angle, is 5x minus 60. So if we want to find x, y, and then the measures of all of our angles, we're just going to plug things back in. So let's go. We know that a segment bisector cuts things in half. So we know that AD has to be equal to CD. So I can set these equal to each other. 2y plus 4 equals y plus 12. So I've got subtract y, subtract 4 from both sides, y equals 8. All right, now to figure out x, I know that that's got to be a right angle because it is a perpendicular bisector. So I have 5y minus 60 equals 90. So I've got, 5x is 150. So x is 30. Now I'm going to find all my sides. Let's see. AD was the one I did in green. So that's going to be 2 times 8 plus 4 is 20. DC is the one I did in blue. So that's 8 plus 12, which is also 20. Woohoo, we got it right. They had to be the same because it is a bisector. And then AC would be the whole thing for 40. Perpendicular bisector theorem. In a plane, if the point is perpendicular to the bisector of a segment, then it's equidistant from the endpoints of the segment. So what that means is because we have C that is on the perpendicular bisector, it means that AC is also got to be equal to CB. Triple check, make sure I just did that right. AC has got to be equal to BC. Good. Because it is on the perpendicular bisector, you have to be equivalent to you. Because these are cut in half perfectly, so that is also cut in half perfectly. AC is equal to BC. Conversely, if I know that these two are equivalent, that means this has to be a perpendicular bisector. So I know that these two are going to be equivalent. And, okay, so if C is equidistant from A and B, then DC is my perpendicular bisector. DC is my perpendicular bisector. So you know now that that is a perpendicular bisector. So we know that these are equal, and that's at 90 degrees. We're going to use this in a lot of different ways. Okay, I know that these are equal, so that means, and this is on this point, so it means I know that AD has to be equal to DC. So that means R is equal to 8, and then AC is this whole thing is equal to 16. Again, I know that's equal to that. So it means this has to be a perpendicular bisector, and this has to be equal to this. Let me do it in a color you can see. So x equals 24. And let's see, AD is just this little piece. So 24 minus 8, AD is 16. Because these have to be equal. That makes perfect sense. Okay, LM is a perpendicular bisector of NP. The length, NP, with a perpendicular bisector. So we're going to draw right in the middle and go right down the middle, and I've got LM, perpendicular. The length of LN is 12W plus 7. The length of LP, it's got to be equal because we know it's a perpendicular bisector, is going to be 15W minus 5. So now we can set those two equal to each other because L is my perpendicular bisector and is on my triangle. 12W plus 7 equals 15W minus 5. So I have a 3W over here, plus 5 gives me 12. W equals 4. And then let's see, LP, which one is it looking for? It's looking for LP. So I can plug it in and get 15 times 4 minus 5. 15 times 4 is 30. 60 minus 5 is 45. And let's triple check because 12 times 4 is 48 plus 7 is 45. Nope, hold on. What have I done? 55. See, this is why we check our work. Great. There are 3 more to practice on your own. I will put the key up so you can double check after you have finished those. But we also need to talk about angle bisectors. So it is a line segment array that divides an angle into 2 equal parts. We know this. We've done this before. So an angle bisector is going to cut you in half, which means you are going to be equal to you. An angle bisector can divide an angle in 2. So I can have as many angle bisectors here as I want. I could have one that divides A in half, so you'd be equal to you. I could have one that divides C in half, so that'd be equal to that. And then I could have one that divides B in half, so that would be equal to that. But it just sets up some more equality that we can do. So we need to make sure we know how to name our triangles here. So if CTE, nope, it'd be great if I read the right things. If RTE, TA bisects this angle. So we know that these 2 angles are going to be congruent. The measure of RTA, this one, is 3y minus 4. The measure of ETA is 4y minus 17. They have to be equal. It's an angle bisector. 3y minus 4 equals 4y minus, wrong color, minus 17. Now let's solve. Move that y over here. So y equals plus 17 on both sides. Y equals 13. So I can plug those back in. ETA is the one I did in green. So 4 times 13 minus 17 is 35. So I just did 4 times 13 minus 17. And then on this side, I should get RTE should be the entire thing. So it should be 35 times 2, but let's triple check to make sure I got everything right. So what's 3 times 35 minus 4? Let's see if we got it right. 3 times 13 minus 4. Whew. 35, good. So we have 35 and 35. RTE is that entire angle, RTE. So it's 7. Angle bisector theorem. If a point is on the angle bisector, then it is equidistant from the 2 sides of the angles. So we're just going to check out the key really quickly, make sure that we write down all these pieces exactly right. So if AD bisects BAC, and then I have perpendicular, so we've got some right angles up in there, and I got some more right angles up in there. It just means that these two sides are equivalent. BD is equal to that one. Conversely, if we know these are equal, then we know that my angles are equal. They have to make right triangles for this to be true. All right. Solve for the variable and the indicated lengths. Great. If we see, I've got right angles here, and basically we know this is a shared side, so we know we can use HL is basically what's happening here. So we know that these two have to be equal to each other. 2x plus 20 equals 5x minus 37. 3x equals plus 37 is 57. 57 divided by 3 is going to be 19. And then the measure of FGI. So FGI, we're just going to plug it in. We should get the same answer both times. Let's triple check. So if I have 2 times 19 plus 20, 2 times 19 plus 20 is 58. And then FGH is going to be the whole thing. Whoops, highlighter. FGH is the whole thing. It should be 58 times 2, but let's triple check and make sure I didn't make any mistakes. So I can just plug back in. Let's make sure I've got 5 times 19 minus 37. Let's make sure that equals 58. 5 times 19 minus 37 is 58. Good. So now we have 58 times 2, which is 116, or my entire angle. Great. Yet again, right angles. I'm going to have, these are going to be equal because it tells me these two angles are equal. So this is more angle side, but we're proving that these two triangles are congruent. So yet again, I can do 3x minus 4 equals 8x plus 11. 5x equals 15, x equals 3. And then it wants to know the length of AD. AD is just that one. So let's see, 3 times 13 minus 4 is 35. Triple check my work. If it should be 8 times 3 plus 11 should also be 35. Good. All right, yet again, I know these two are equivalent. I have an angle here and I have a shared side, that's HL. I know that these two have to be equivalent to each other. I got YZ as an angle bisector. So x8 minus 32, that's WZ as an angle bisector, plus 3. 5x equals 35, so x is equal to 7. Check my triangles. XWZ is that little guy, so 8 times 7 minus 32 is 24. I'm going to check my other one just to triple check. So 3 times 7 plus 3 is 24. Good. So that means my whole thing that's XZ W. That's this angle. Ooh, that's a different angle. That's fun. All right, so we know that this guy is 24. We know that this guy right here is 90. So now I can find my green angle by doing 180 minus 90 minus 24. So 90 minus 24, 66. All the things we know about triangles. Y'all are brilliant. All right. Shared side again, but we also know that these are equal, so that is an angle bisector. So we know that these two are equal. Now I've got HL, but now I can solve it. I'm just going to go ahead and put the keys up. Y'all do this on your own and then check my key to make sure you're good. Homework is on the back.